crazy things he does in an airplane. Curtis learns a number of techniques for building an aircraft at home. We fly a Cessna Caravan into the picturesque town of Atlin. And we see how backup instruments could save your life. From the Boundary Bay Airport, this is the Aviators. For most pilots, flying up into a stall and then hurtling toward the Earth seemingly out of control would be a nightmare. For aerobatic pilot Rick Volker, it's just another day at the office. Rick flies a colorful Sukhoi Su-26M aerobatic plane at air shows all across North America. During the chilly winter off-season, our own Sarah Rapenda had a chance to talk to Rick about his career as an aerobatic pilot.
So Rick, when you got into aerobatics, you didn't even have a pilot's license.
No.
What pushed you to go ahead and get that done?
I saw a show on Wild World of Sports on TV. I saw biplanes flying, doing amazing, extreme, crazy things, and I said, I've got to do this. So I mapped it all out. I went to the local airport, found a flight instruction, got my private pilot's license, found experts in the field, talked to them, and they helped me map it out. I mapped out aircraft by aircraft that I had to jump to. I got into the competition arena, and with a flying instructor in aerobatics, I learned how to idiot-proof myself so I couldn't kill myself doing stupid things.
Right. What was the most difficult part of learning aerobatics?
That would be getting sick. I used to get sick every time I got in an airplane.
Really?
Doing anything. It caught me by surprise because I'm pretty good in a car and a boat, but I beat it, though. I beat it by first wearing a little watch that pumped electric current into my median nerve in my hand.
Oh, that's really cool.
Mm-hmm. It worked. It works for the Air Force. It worked for cruise ships, so it worked for me. And then just the repetition. Now I have an iron stomach.
Oh. Now, you're obviously in shape. What does it take in order to maintain the physical fitness for aerobatics?
Very old pilots have a very good time with G's. They have hardened arteries. They're like firm pipes. Blood doesn't pool anywhere. The big problem with them is fatigue. These maneuvers take a lot of straining. You're always straining in your gut, and you're straining in your neck, and you're straining your legs. After a while, it becomes automatic. And if you're straining for 20 minutes of flying, you can be exhausted unless you're fit. And weightlifting tends to be the best way to increase G tolerance.
After a break in performing, can you just jump back in the airplane and do it like you did last summer?
No.
Okay.
No. If I jumped in the plane right now after about 3 months from doing aerobatic flying, I'd be unconscious. I have to gradually build up a little more G each day. There are some really bad side effects you can get if you jump in it too quickly. Something called the wobblies.
What is that?
The wobblies, if you try negative Gs, now that's the equivalent force of being swung around by your ankles all around in circles. So the blood goes in your head. If you get too much of that too soon, it breaks some of these things in your inner ear, or ruptures the blood vessels in your brainstem, something like that. And you're just, the world swirls around and around and around, and it takes you a week to recover. And that's how you know.
Recommended to
that's
just
how you
jump
know
in.
you can't
Okay.
just jump right into it. The plane I fly is a Russian plane built by Moscow to win the World Championships. It's built like a Caterpillar tractor. A lot harder than any person is, and you have to really hit the ground to break it.
So take us through what's going through your mind when you're in the middle of a show, what you're doing, what's happening.
I have a complex series of maneuvers that I've already rehearsed many, many times. But new every day are the wind and weather conditions. So I have to stay a certain distance from the crowd. I have to stay in this defined legal area. The wind is trying to ruin it every second. So I have to compensate in every maneuver. I have to put a bent on to just kind of keep it and tweak it, but without looking like I'm doing that. So that's a constant challenge. On the ground before every flight, I visualize for 15 or 20 minutes exactly what I'm going to do in the air. I'll actually go through, and you'll see people walking through, and they'll be going like this and make little movements and like that, and they'll spin around, and you're just rehearsing in your mind everything and how you're going to compensate for that wind.
And then once you're in the air, what's happening?
If you've practiced thousands of hours, you're following back to just what is, it just becomes almost innate.
So what feels right?
It just feels normal. You're just going through, you don't even have to think about them. And you're tweaking little things. You're just changing things to alter presentation. Trying to get the aircraft in a 4-point roll instead of being exactly 4-point on a heading. You're making the 4-point a little further, so those people right there can see exactly the top of the airplane.
So you really are, you're like a performer. You're trying to enhance it for the spectators.
That's what it feels like.
Okay.
It sure is. And the crowd gets me very pumped up. To see a lot of crowd, to see people watching, it's just amazing. It's just, I fly better. I'm more on the edge. I get more adrenaline. Everything's tighter and cleaner. I'm not really performing for everybody. I'm picking out a couple professionals who I'm trying to impress on the ground, and my own self too. It's a competition against myself. I have to be better than I was before.
Do you think that there's a certain set of mental skills that people have to be a pilot, like an aptitude for specific things?
I do. It would be spatial relations ability.
Okay.
And when I was in 6th grade, I took a test that tried to tell me what career I should follow and told me I should be either a pilot or a dentist.
Really? So you became a pilot. Now, what is your day job?
I'm a dentist.
Really?
You'd be excused if you thought that this aircraft was a $600,000 factory-built aircraft. This Lancer ES is produced in kit format and sold to builders construct at home with their own engine, interior, and instruments. For less than half the price of a factory-new aircraft, you can have an aircraft like this that takes a family of 4 across the country at speeds in excess of 200 miles an hour. We're going to show you some of the skills necessary to build an aircraft like this at home.
The tradition of building airplanes at home goes back to some of the earliest aviation pioneers. Many of today's leading aircraft manufacturers can trace their roots to aircraft built in a garage or barn. Today, home building continues to be a very popular way to get in the air. Mostly sold in kits, you can find everything from home-built helicopters, to ultralights, to all-composite flying boats. While some of these may seem fairly advanced, with the proper tools, a big enough garage, and a lot of time, building an aircraft is within the reach of most pilots. Our own Curtis Arnold stopped into a builder's workshop at a recent fly-in, where he was shown a number of the techniques necessary for building your own aircraft. First up was learning to construct a wooden wing.
Ever since the Wright brothers, people have been building aircraft out of wood. In fact, myself at home, I'm still constructing an aircraft out of wood. We're here with Art Wazak and Jim Scroggins, who are working on this peat and pole wing. So Jim, the first question I'd like to know about is, are there special kinds of woods that you need to use when you're building airplane parts?
You need to use stick of spruce, and you can also use Douglas fir. And the ribs can be made out of red cedar, about anything, because all they do is keep the fabric apart.
A traditional wooden aircraft wing has a number of distinct parts. The spars are thick wooden supports that run the full length of the wing. The spars have to be very strong as they carry the majority of the aerodynamic load that's put on the wings. Most small aircraft wings will only have 1 or 2 spars. Forming the actual shape of the wing is the job of the ribs.
Now it looks like somebody get a lot of practice building these ribs here because it looks like a lot of identical pieces that go into an airplane.
And you get your plans, they'll give you a full-size rib, and you got to lay it out on a board, and then put these blocks wherever you need to put them to hold the wood in place. And after you get this in, then you can lay all the pieces in, cut all the wood first, and then put the gussets on. You can either nail them or staple them.
Perfect. And so you put the rib together and you glue it up and you staple it, and you said you come back the next day, and then what do you do?
Come back the next day, you can pull it out of the jig, start at one end or the other, lay it aside, lay up the next one, and then when you get that laid up and stapled, then you can take the other jig and put the gussets on that one. So you can make a rib a night, or if you got 2 jigs, you can make 2 ribs a night. So about a month or so, you'll have all the ribs.
Once the spars and ribs are assembled, the wooden frame is then covered in fabric. One of the advantages of using wood is that it can be shaped and manipulated fairly easily. Jerry Hand showed Curtis just how easily a wooden propeller can be formed.
We make wooden propellers because they are relatively inexpensive, and it's been around for a long time.
So it looks like with this machine, you're taking what looks like a very nice propeller blade and using that to make another propeller. How does that work?
This is a duplicating machine. It copies the existing shape of a propeller or a pattern that I have here, simply by using a router bit that turns very fast and carves out the wood in the same pattern as the shape over here.
While wooden wings and propellers are very common, aluminum and other metals are the predominant materials used in home-built aircraft. Companies such as Zenith or Vans ship their aluminum aircraft kits in pre-cut, pre-punched, and in some cases pre-drilled pieces. These pieces are then joined together using a pneumatic rivet gun and metal rivets. Home builder Frank Baldwin helped Curtis try his hand at riveting.
So you can see that there's a dimple in the end of the rivet gun that matches the radius or the convex surface of the rivet. And you've got, what do you got there?
This is the bucking bar. It adds weight, and you have to have more pressure on this side than the back side. So let me hold this for you, and pull the trigger when you're ready. And I have them lined up here. Okay, that looks good.
So you can see the head looks exactly like it did when we put it in. And on the other side, we've mashed the rivet so that it's spread out and filled the hole.
This simple process is repeated over and over again, and a home builder would have to complete hundreds or thousands of these to complete an aluminum aircraft. Another method of constructing aircraft is using composite materials. This method was made popular in the late 1980s by Burt Rutan designs such as the Very Ease. Composite construction may seem complex and even scary to some people. However, as Curtis found out, it's actually quite simple.
Composite is basically, for real keep it simple, is taking two unrelated materials and putting them together to make a structure out of it.
So what we're looking at here then, I guess, is the filler material that's been carved out to shape.
Yes.
Some type of a web that's been put in to add some structural strength.
Yeah, this is actually the spar for the main wing right here. It's a C-spar, and that's also made with fiberglass cloth. It's a special made cloth for building spars, but it's the same chemically as this cloth here that we use for the skin.
Now the whole thing's covered over with skin, and you paint on a number of layers of the epoxy. And then how do you get this really nice smooth finish?
Well, this happens to be done with what we call peel ply, which is a piece of Dacron that as the product is still wet, we'll take and put it over the top and wet that out too. And then when this all cures, we'll peel it off. When it peels off, it'll leave a nice, even layered surface on it.
Regardless of the techniques used, the majority of home builders begin with either a kit, aircraft plans, or the help of organizations such as the Experimental Aircraft Association. Kit building companies offer these aircraft in various stages of construction. With some, you simply have to put on the wings. With others, you may find yourself using all of these techniques in building the aircraft piece by piece. This isn't a quick process, and the average home-built aircraft can take anywhere from 1,000 to 3,000 hours to construct. The payoff, however, is not just getting into the air, but knowing all the hard work and determination it took to get you there.
Hi, I'm John Lovelace, the creator and the producer of the Aviators, and as the producer of the Aviators, I can pretty much pick any of the plum jobs. And so today I've done that. We're all the way up at the north end of British Columbia in what I think is the most beautiful place on the planet. It's Atlin, British Columbia.
Ringed by the rugged coastal mountain chain and on the shores of glacier-fed Atlin Lake lies the old gold rush community of Atlin. Once called the Switzerland of the North, Atlin sits at the very top of British Columbia and just east of the Alaska Panhandle. The only way to access this town is by road from the Yukon or by air. John has been flying floats in the Canadian wilderness for over 25 years. Departing from the Yukon capital of Whitehorse, John flew into Atlin in a Cessna 208 Caravan on floats. While dockside, John spoke to one of the owners about the aircraft.
Tell me all about this beautiful flying machine.
Well, it's we've had it for over a year now, and got to put about 150 hours on it so far, and I just love flying it. It's a great machine. It's quite a lot of load, and it's got a fairly good speed of 147 knots per hour. On floats, about 200 on wheels.
The Caravan was first developed by Cessna in 1982. Since that time, a number of variants have been produced, such as the larger Grand Caravan and the Cargo Master and Super Cargo Masters, designed for FedEx. The version Mark was flying is powered by a 675 horsepower Pratt & Whitney turbine engine and can go quite an impressive distance.
And so how many hours can you put in the tanks?
It's got a 6-hour range at lower altitudes, and at higher altitudes you probably get up to 7 hours. So it's got long legs.
And you're rolling along at 147.
147 knots, yeah.
And that's in cruise.
That's in cruise.
And they got lots of power too, right? You can load them right up.
Yeah, it's not a bad performer. I mean, they don't perform maybe quite as good as Beaver or Otter, but they perform fairly well, and plus they got good speed.
So, and how many people can normally can you get on for a typical mission?
Usually 6 to 8 people if you're not with full fuel naturally, but it's got 10 seats in it. If you convert it to the wheels, you could fill all 10 seats.
The large passenger capacity of the Caravan has made it a popular choice for regional airlines. The aircraft's rugged, fixed landing gear makes it easy to land on grass strips, and the amphibian version can go just about anywhere.
And you've got, tell me about the floats.
They're Whipline 8000 amphib floats, so it's a very versatile machine. You can get into the far northern lakes and fly right back out to the international airport if you want, and so it's very versatile.
The Whipline 8000 floats are also available on the very similar de Havilland Single Otter. One of the big advantages of the 8000s is their impressive watertight storage, some of the largest in the industry.
Let's go out and have a look at these storage compartments.
There's 4 storage compartments.
And I'm just going to jump in and whip
2 on each side,
and open this up.
and each one holds 100 pounds.
Yeah, so that's amazing. Look at the storage there. It's the size of a trunk. And they open up, and you've got basically 2 of them. And these Whipline floats are pretty reliable.
The Cessna Caravans are not small aircraft. The 675 model is just under 38 feet long, and the Grand Caravan adds another 3 feet to that. According to Mark, though, the performance is very good, even when compared to smaller, more familiar Cessna floatplanes.
How does it handle? So a lot of people out there are familiar with 172s and 206s, but how does the Caravan work?
It handles very well. It's a very stable aircraft. With the long body and the large tail, it has a tendency of sitting very, very still, like it's not much yaw, like on some of them. I find it very stable. I've actually used to flying a 185 on 3430s, and if you load that to gross weight and load this to gross weight, I feel there's not much difference in performance to take off.
With the list price of a Caravan slightly more than $2 million, it's certainly not for everyone. But when it comes to buying the best in its class, the Caravan delivers speed, range, and useful load, and some terrific northern wilderness destinations. With products to be used thousands of feet above the earth, manufacturers in the aviation industry have to have extremely high product standards. This applies not only to companies building main components, such as the airframe or engines, but also to the makers of the aircraft's displays and instruments. In everyday flying, pilots trust their lives to what their instruments are telling them. Mid-Continent Instruments, based in Wichita, Kansas, manufacture a variety of aircraft instruments, including their flagship product, the Lifesaver Gyro. To find out more about the precision that goes into every instrument, the aviators went to Kansas and met up with Mid-Continent President Todd Winter.
Well, Mid-Continent started as a service company, and we started because the aviation manufacturers were here. And we were doing service work for some of our key customers, and they actually approached us and said, "We have a problem. Can you help with this?" And they asked us to design replacement instruments. So we started on a small scale with just a few people, building very specialized parts, and really growing from there to where we then began to develop our products that we could sell in the aftermarket. So instead of designing to a specification, we would initiate the design.
Primarily focusing on general aviation, Mid-Continent has built a reputation around producing a high-quality product that's thoroughly tested. To achieve this, they employ manufacturing techniques that minimize the potential for defects. Lead technician on the Lifesaver Gyro line, George Hooper, spoke to us in one of the labs where the final assembly is done on the Lifesaver Gyro.
This lab here is where we build the instrument itself. The machining work is not done in here because of the cleanliness. You know, there's no grinding, sanding, or anything that needs to be done. If we have a part that is not exactly the way it's specified, we reject it and send it back to parts and get another one. This lab is kept at higher levels than a hospital's cleanliness. We have filtrations on some of our systems here down to 0.5 micron, which is way smaller than even a human hair. So this is solely set up here for manufacturing. Everything comes in sealed or in bags. Our bearings are all individually sealed and packed so that they have no chance of being contaminated. When we apply them, they're done with clean hands, or fingers are covered, or with tools that are clean.
Mid-Continent's signature instrument is the Lifesaver Gyro.
The Lifesaver Gyro is an attitude indicator or a horizontal or horizon indicator. Some people call it an artificial horizon. Basically, it lets the pilot know the orientation of the aircraft relative to the Earth.
An attitude indicator is going to basically tell you if you're nose up or nose down, which is called your pitch, like in an aircraft like this. Pitch up, pitch down. Also, when you roll right, roll left, and you're in a bank situation, an attitude indicator will give you that. It will tell you how far left, how far right, how far up, how far down you need to be, or that you are when you're flying in the sky.
The Lifesaver uses a gyroscope to display attitude information. Unlike traditional vacuum instruments that use air to spin the gyro, the Lifesaver's gyroscope is operated by electricity connected to the aircraft's main power.
So inside an attitude indicator is a rotor, also known as a motor, and that provides the gyroscopic action. It spins, creating the stability that allows the airplane to turn while the gyro stays in the same place, giving you a reference of pitch or bank. In a vacuum-driven system, the air pushes past that rotor with little fins around the outside of it. That spins. That may spin at anywhere between 15 and 25,000 RPM. In an electric-driven system, it basically uses the aircraft's power to create a three-phase signal which turns that rotor and produces the exact same action, just with a different power source.
Instrument flight rules, or IFR, are a set of regulations for when pilots can't see where they're going. This includes flying through clouds, storms, or while flying at night. Knowing the aircraft's attitude, altitude, and airspeed are always important to know, but they become crucial when flying IFR.
During a normal flight, when you're out at 7,000 feet, you can still see the ground, so you have reference as to where you're at. But during the night or during a storm or in the clouds or when you get upwards in 20,000 feet, you start losing your bearings, and your body can actually play tricks upon you as to what's going on. So you have to be able to trust what this gauge is telling you.
Pilots may find their aircraft flying upside down if they experience disorientation and fail to properly reference their attitude indicators and other instruments. In the past, this has led to pilots flying their aircraft into the ground while thinking they were actually pulling up. So what happens if your aircraft has an electrical failure cutting off the power supply to the Lifesaver Gyro? Not a problem. One of the standard features of the Lifesaver is that it has a built-in battery backup that's able to supply up to an hour of internal power. This has led to the Lifesaver often being used in conjunction with glass cockpit systems. Regulations do vary by country and aircraft, so this instrument may or may not be required for your aircraft. But regardless, many owners are insisting that the Lifesaver Gyro become part of their panel.
And if you think about the circumstances, if you're in a difficult situation anyway, your IFR, maybe you're on approach, when you have an unanticipated emergency or situation, the easier it is to transition or to check against your backup indicator, the safer it's going to be. You've got your hands full anyway. So having a second attitude indicator is often recommended and practiced by many people.
The Aviators, for everyone who has ever gazed skywards.
For more information on today's segments, visit www.theaviators.tv.